We're moving to development, leaseholders. We drill about 250 wells a year there. These are all horizontals using a slick water completion design. And then I also work in the DJ Basin in Colorado. That's our most developed basin. We have about 1,500 wells. We drill and complete about 365 wells a year. And I'm going to talk about the water infrastructure and our recycling efforts there. But real quick, just as a backstory, kind of water in the United States, 80% of water that's used is from the surface. Half of our drinking water comes from groundwater wells, and 30% of stream flow is discharging into streams from the groundwater. In areas like where I grew up in Kansas, there's massive freshwater aquifers that have been drawn down by a variety of industrial factors. So understanding this hydrologic cycle is very important for us. A number of us operators have gotten together and sort of putting together this life cycle of water diagram throughout oil and gas operations. It includes storage and drilling and completions, and then kind of the different components and groups within an oil and gas organization that all touch water. So for a long time in oil and gas, U.S. onshore, for instance, you have oil, gas, water coming to the surface. Gas was thought of as almost a waste product, right? And water's thought of as a waste product. So we flare the gas. And then after a while, we get the understanding that it's actually a product. It has economic value. The right thing to do is to capture it. And we've moved to where we capture the oil and the gas. Now the shift in thinking of, this is water that's been trapped under the surface for a long time, and it potentially has a use. Not just in oil and gas, but potentially in some other industrial settings, potentially for agriculture. There are some instances where it is discharged to agriculture, but much of that is a function of the technology, advancement in technology, and the costs associated with it. Also, it's a function of the water quality of that produced water, because the produced water coming up, it varies widely. So I'll move in now to kind of Anadarko's, our vision of how we see things in the DJ Basin in Colorado. And let me preface that with the DJ Basin is in a very highly populated area. The city of Denver is there, where Dr. Wilkins' Fort Collins is there, and there's a corridor where we're working in and around people. So we had to come up with some different solutions than we've used in other basins. So first and foremost, we want to decrease dependence on disposal wells. In that basin, there have been a handful of induced seismic events. The zone in which we inject into is very close to basement rock, and there is some natural faulting that occurs throughout the basin. So, when we see these induced seismic events, we need to come up with alternative strategies for water management. Being efficient with conveyance, and then reducing our demand for fresh water. In that area, when you look at the state water plan for the next 10 years, with the growth in population, there's definitely a deficit that will be seen in the next 5 to 7 years in water. And then lastly, it's sustainability. We have the social license to operate aspect with all those people around in that area, and then also we have to make a profit to stay in business. So in 2012, we started developing within our pipeline corridors for oil and gas. We did a water infrastructure, it's about 282 kilometers. And I'll stop here and go with conversions because the U.S. barrel that I use is roughly 160 liters or so. But it was able to serve 4 frac crews simultaneously. And the stat I like is that by pulling the trucks delivering the water off, it's the equivalent of 45 trips around the moon. So Colorado is also in non-attainment for ozone, so the emissions reduction's huge for our operations as well. So to date, we've delivered 225 million barrels, we've reduced the pad size from around, that says 100, but I've seen as many as 400 frac tanks on a location down to around 20. So just the footprint decrease is huge, especially being in and around so many people. And then we've also been able to leverage it and use it to sell surplus water to other customers in and around the area. So what it is it's fed by different sources. Mostly it's about 70% surface water, but there's also some brackish type groundwater. There's a well system. We use irrigation ditches, reservoirs, tanks, pumps, filters, all sorts of things to get the water to the location. And then once the buried pipeline, once it gets to close to the location, we have hydrants that are above location where we hook up anywhere from 4 to 8 inch lay flat hose that will deliver to the frac crews. So just for an example, the upper left, this would have been 2011 before we started this system, and you can see all those tanks. There's probably 200-300 tanks on that location, and this would have been a location from last year where the only tanks you have are over here, and then what we would call our staging tanks, which holds 1 stage of water for a frac. And actually, this picture here, when we were first in developing our field, that one of the upper management saw that and said, well, there's a body of water right there. Why are we trucking in all these? We didn't have the rights to that water, but what it did is it led to the dialogue and discussion with regional partners to work this out. That's kind of our freshwater conveyance system. I'm going to move into how we handle produced water and some case studies and pilot tests we've ran around the treatment of produced water. So in our state, there's 3 regulatory bodies that really have a hand in it. So there's one that regulates quantity, which would be the Division of Water Resources. The Department of Public Health and Environment regulates quality. And then we have the Colorado Oil and Gas Conservation Commission, which touches all things oil and gas. So we had 3 recycle options we were looking at. Like, we could take the water as is and put it into our freshwater system. But what that does is then it immediately makes it a waste system, and it implicates, has different regulatory implications, and there's also, the thought of it was constructed for fresh water, it's high-density polyethylene. Is this appropriate if we would put produced water in? So we've ruled that out pretty much off the bat, because it does have a value as a raw, non-potable water delivery system. Second, we've done something similar to this in the past, but we had a centralized treat to a certain spec for fracs a facility, but what we wanted to do is try to do a mobile type facility so we can move around with the frac and not have to truck in, truck out, and we'd be able to pipe to the frac. And then lastly is, hey, what do we do to recycle, treat, and keep the water on the surface, whether that's discharge for agriculture, to stream, or for another industrial use? So we developed a team, cross disciplines, various groups throughout our organization, and just kind of put our heads together and made a process for all this. So what we came up with is we're going to put out a request for a proposal for a mobile system. And then we came up with a scorecard where we're looking at cost, safety, technology, operational philosophy, et cetera. And so we went through 10 different vendors. We did an independent review. We also had a group from a different asset do an independent review. Blinded, and we both came up with the same vendor that we wanted to use. So we set some effluent targets, total iron, less than 10 ppm. We need to get rid of the suspended solids. Bacteria control, as was presented earlier, we knew we couldn't get to 100%, but that's the target we gave them. We do see the bacteria issues in our wells also. And H2S is a big deal for us, and then pH adjustment and oil. Oil mainly for sensor fouling on the frac. So the process we came up with is fairly simple. Oxidation, pH adjustments, clarifying tanks, weir tanks, aquatic filters, and then we'd pump it down to our frac where we'd give it 2 different biocide polishings. So this is what our first pad looked like. These are going to be 4 separate pads. Each pad has 7 to 8 wells on it. And what we found is the frac would be set up on, we had 2 different fracs going on 2 of the pads, and then we'd set up an offset pad and then pipe down to the frac. So we'd truck it into the location, pipe down to the frac. And as the fracs moved, we would then either backfill where the frac was or move to another location where they're going to be. So we started following the frac around, and we did this for about 13 pads, I believe. This is a drone view of what it looks like. You have your water in. We also did some treatment of what we call our ARF water, which is dewatered from a drilling mud facility, and then our flowback water as well. So treatment's there, and then it would pipe up to the frac. Some of the learnings we had is water hauling truck drivers are always a challenge. Water storage, what's the appropriate amount of upfront storage? How do we manifold it so that we can actually keep the process going throughout it? We did get a lot of experience with water chemistry, pad safety, and then we were able to drive down costs throughout the program. So what we found is by able to ramp up our volumes and economy of scale, we were able to get about a 26% reduction in cost per barrel. And we had a targeted barrel of about 1.1 million liters per day is what we were shooting for. So that being said, we decided to take the next steps and move into our next pilot, where we wanted to source, transport, treat, and then either discharge or find another end user, I'm sorry. Again, we worked with the same 3 agencies, and they came up with 137 different analytes that they want us to look at. And so we did the same process, and we came up with 2 different vendors and 2 similar processes. So we'd do a sand separation up front. We'd hit it with an oxidizer, sodium permanganate in one, or hydrogen peroxide in the other. We also used a flocculent, alginate, that was a flocculent that was used in the North Sea that worked fantastic. And then we used PAC-L as a polymer. Then we moved from there we went through granular activated carbon and walnut shell filtration, and then we tested out for ammonia removal and some final TOC removal. We looked at advanced oxidation. We also did a membrane bioreactor, finally throwing it through reverse osmosis, which we added the reverse osmosis later as we were kind of looking at these in stages where we could sample along each of the processes to see where that fit for purpose water quality number is. This one's similar, IGF, induced gas flotation, very similar to a DAF. We did oxidation. This one we tried breakpoint chlorination for ammonia removal. Colorado, the streams, they have ammonia impacts because it is a heavily agricultural area. So ammonia really is one of those tricky ones for us. And then finally, again, we did filtration and reverse osmosis. So this is what it looks like. Our little pilot test, one of them, this is the one with the breakpoint chlorination. But the biggest challenge for us is there's a different HSE culture than the vendors. You know, we have to put the health, safety, and environment first in everything we do, but we found that we were not aligned initially, that they were not up to par. We had to stop work a few times and talk about how we're going to get there. Logistics were a problem, and then communication. And these are some of the growing pains of any vendor-contractor relationship. Wins, we proved the technology, aligned the cultures, and we came up with a tremendous set of data to where we were able to pass all the parameters that the state put forward for us. And basically the end would be a discharge type quality, or almost like a drinking water quality water. Ammonia and toxicity testing were our biggest issues. Toxicity testing, we'd have to test on fathead minnows and Daphnia and get a 100% pass rate, which we eventually did. So that being said, in our basin, we're also doing similar things in the Permian and our Delaware Basin. We have the mobile recycling unit that doesn't quite fit our system in DJ now is down in the Delaware working for us, and that's that one there, and they're moving along with our frac down there. And then in the Powder River Basin, we're starting from scratch, which is lovely because we have an opportunity to plan in water infrastructure, plan in recycling before it goes into development. So that's all I have for today, and thanks, and I'll be happy to answer any questions during the panel discussion.
Well, thank you very much to all 3 of our talkers there, to our presenters. I'd like to open up now to any questions from the audience. These can be to individual speakers on points of clarification from their talks, or more general questions for the whole group. Please do remember to wait for the microphone and to say your name and affiliation when asking a question. Anyone there?
Thank you. It's Gary Edwards from the Environment Agency England. A question for Mike of Anadarko. Could you say a little bit more about how the economics of the water treatment stack up for the process going forward? In other words, does the cost of it pose a problem for operators to use?
So that's a very basin-specific question. So, for instance, in the DJ Basin where we did it, it was more expensive than traditional disposal. in other basin, because the disposal costs vary widely from basin to basin. In Texas, it's very competitive, and it's pretty much becoming the norm for all operators to recycle down there. In Wyoming, that's a basin that's just, and these, I can only speak for the basins I know. In Wyoming, because it's in the beginning, there's not a lot of volume of water being generated on the backside. So the discussions we're having now are between operators and with the state of Wyoming to say, hey, can we just pool this water together so it makes it that economy of scale where your cost per barrel is less than what your disposal costs are. And those, we've just started those discussions and dialogues, and they're going pretty well.
Thank you.
So I have a question for Michael. You were talking about the various different microbes, and I'm not going to even attempt to say their names, not being a biologist. Obviously, you have to input solutions as part of the process. What can we do, because you mentioned this sort of right at the end of your talk, about trying to both perhaps promote methane, but also trying to stop all the corrosion and problems to the metals. Is there a different solution we can use or something we can put in the solution?
I think it really comes down to what you're trying to do. Like I say, if you're trying to promote the growth of specific microorganisms, we know how to do that. But that hasn't really gotten any traction with industry yet. With the engineers that run these systems, microbes are bad, generally. That's sort of the overarching thought here. And so, I mean, maybe, who knows, down the line there might be an interest in in stimulating microbial growth in these systems for more methane recovery. I mean, obviously that happens in conventional reservoirs. I think in terms of the controlling microbial growth, something that we're trying to work on right now is get a better handle on where the bugs are coming from. So we're doing some what we call field audits, whereby we basically go on a frac pad during the frac and work out, which tanks they're coming from. Are they pre or post chlorine treatment, and all these various samplings to try and work out exactly where the microbes are coming from. And if you can work that out, then you can target that specific tank or that drill mud with more biocides, different biocides perhaps, and get a better handle on microbial control there. But at the moment, we just know that we see the same microorganisms in these geographically distinct wells, and so it suggests they're being trucked around in water tanks or on drill bits, or who knows at the moment, but it's a work in progress.
Thank you. I think we had
I had a
question.
quick question also about the microbial communities, which is, isn't it too hot for them to live down in where the wells are being fracked? So are they in the column, or where do they survive?
So certainly that's probably the case in some of the wells that do get up to sort of above 120 degrees Celsius. But certainly there are plenty of wells below that temperature in the reservoir. And again, these are microbes that do grow. They're what we call thermophilic microbes, so they prefer higher temperatures to grow. But yeah, generally it seems like salinity is the major sort of chemical or physicochemical control in the communities. But certainly temperature is a key player when you get into some of those basins in Texas where the downhole temperature is pretty high.
Not sure if I'm on or not. Red is dead? No, red is good. So John Shaw, so it's a comment about the microbial-based enhanced production. From memory, there was a company called Lucent in the early 2010 to 2015, sort of in that range. They were doing fairly large-scale experiments with wells. And from memory, the company went bankrupt. So I suspect it's perhaps not a commercial path, or not a commercial path based on the technologies and concepts at that time. Or it may have been the wrong wells, but this is where they were either injecting colonies of bacteria or stimulating existing colonies in more conventional settings by adding, let's say, fertilizer, food, whatever, for the bugs to stimulate them, and it just didn't work.
Yeah, I think it's always a case of finding a suitable feedstock that's economically viable. A lot of these methylamine compounds, so those amine groups with the methyl groups hanging off them, the raw materials are relatively expensive. So if you can find some sort of cheap feedstock which will yield those products, then you might be in business. But yeah, it's certainly I don't think it's being seriously considered. It's more an idea that's been sort of swirling around the back of our minds for a while now.
You know, the kinetics, I think you'll find, of the methane production may not be sufficient to justify the added infrastructure and so on. But
Right.
that's I'm not an expert. This is from memory.
Yeah, and actually that brings another point as well, is actually one thing we've struggled with is actually trying to quantify any new biogenic methane versus old biogenic methane. And I mean, I know there are sort of lots of nice isotopic methane analysis tools out there, but it's a question I often get asked, you know, if I talk about the methanogens in this system, people of course ask, you know, well, how much methane are they producing downhole? And I can't answer that right now, so yeah.
From memory, there's a group of researchers at Alberta Innovates in Canada that actually does work on that. And there is a body of literature that's public that's available that might help you.
Okay.
Thank you. I'm Jenny Stevens from Northeastern University in Boston. My question is for you, Mike, about water contamination and public health concerns. And in the United States, there's a lot of concern that oil and gas is not heavily enough regulated and a lot of negative public health impacts. So I just wanted to hear your perspective on that and any more insights you have.
So it's a huge topic in the U.S., and I've worked in different industries as well, and groundwater contamination, typically it would be seen on from a spill or a release. We haven't seen where we're contaminating groundwater from the well itself. It's more of a surface issue, and that's been pretty consistent with what I've seen in other industries when I was in consulting. But you know, shallow groundwater potential for contaminations, it's something that really having good protections in place is very important, whether it be secondary containments or processes for handling fluids is very important as well.
If I can add anything to this, I mean, we ran just some simplified models, I mean, in the context of our project in this. And well, let's put it like this. Let me subdivide the assessment of groundwater contamination by considering two sources of uncertainty. One, the model that you're using, because anyway you are uncertain about your model, and two, your knowledge about the subsurface. So you have geology and the distributional parameters. In both cases, we actually found that which was consistent with what we saw also in some documented literature, that there is, of course, a probability that there can be some thresholds of concentrations which are surpassed, but still it's very small and it's manageable and it's quantifiable. So in that case, depending on, and it relies also on mainly on operational procedures, which can be controlled to some extent. So my take on it is that we should be able actually to manage and to quantify the impact that there can be on the groundwater quality. And that is possible and is doable, I mean, at this time.
And I can follow that up with, in Colorado and Wyoming, we do what's called baseline water quality studies. So prior to any disturbance or prior to spudding a well, we'll go in and we sample the water wells that are in proximity. Each state has a little different variance on how far out you go, but we'll sample it, look at a host of parameters, and then once we complete the well, within a year we'll go back. And so we do that for 3 years. We take 3 different sets of samples and do an evaluation of the groundwater quality over time.
I have a question to all of you and possibly to people on the floor as well. Shale gas is definitely a controversial issue, and Perhaps what's less controversial is that early public information campaigns were pretty much a disaster, with the kind of headlines, certainly in the UK, we see being very anti, and in the US it's similar, partly due to some of the risks you've said and others that have been mentioned earlier. So given that, and a lot of misinformation out there, a lot of this strong opposition, how can you take what you've been discussing here and wide risk in general and make it accessible to the public, make it neutral or open, and make it comprehensible?
It's the million-dollar question, I guess. I think, well, I guess I can speak to, I've been involved in a couple of projects, and I mentioned some of our fundings through the National Science Foundation, and the National Science Foundation in the US has a large public outreach component. And so we've done a lot of sort of workshops in the Appalachian Basin, worked with extension offices across the state of Ohio and into West Virginia, just trying to get people real information and sort of trying to demystify it. Like you say, that can backfire, and I mean, people are somewhat reticent to hearing from sort of experts in the field sometimes. But at the same time, I think certainly out in sort of rural parts of Ohio and West Virginia, where we did a lot of our work, people did seem to be fairly receptive to it, and those are the areas. I mean, it's going on in people's backyards. There, it's a rural area. It's happening in people's backyards, and so they can certainly see the economic benefits of it. But of course, like you say, there are occasionally these sort of negative impacts as well, and so I think it's really just a case of getting out there and telling people what's happening and what safeguards are in place, and yeah, just keeping that dialogue going.
And for us, you know, our Wyoming and Texas operations are very rural, so we don't get much feedback from stakeholders. The people that are out there we work with on a day-to-day basis. In Colorado, where you have a high density population, what we found is doing it at the local level, and when we start working in an area, a community area, we'll do a town hall where anybody can come out, and we do question and answers and mingle, and just mostly what we found, to be frank, is they're not worried about groundwater contamination or fracking. The things that drive them insane is trucks driving too fast, dust on the roads, mud on the roads, noise, light pollution. Those are the big ones that they really care about, because they're more, you know, their kids are out front playing. If a truck's coming by, that's where they see the issues as being, and really it's when you can hear these issues, and then we can educate what they care about. We can educate our people on location, like before you start a job, look to see where your lights are pointed at nighttime. You know, just simple things like that. But really, it's having more of that one-on-one on a local level dialogue. As far as more of a wider perspective, I don't know the answer to that question. We haven't really engaged in that.
Well, in my experience as a university, we try to percolate these new concepts, let me call them new, okay, through our educational program. So we have shifted a little bit the focus of, for example, in my class, I teach both the petroleum engineers and environmental and civil engineers. And we have always tried to have let me say, communications between the two classes, so to teach or to show petroleum engineers issues which are related to the environment, and to show environmental engineers how they can serve best in the concept of circular economy, the oil and gas industry. We do it at the educational level, and we also try to engage communities in small projects through focus groups, which are actually organized through some of my colleagues who work mostly in social sciences, and they know how to structure in an effective way these focus groups. We also organize, which I found were actually very effective. There was last week the European Night of the Researchers, and during that week, and we organize also other events during the years, which are open to high school and intermediate school, let me call them kids, okay, without being disrespectful. And we try to engage them on these kind of problems by using simple language and not using the word probability, but using the word chance, for example, or likelihood, which is more than 2 syllables, which is okay. And we actually found quite a lot of people who are interested in at least having an idea about the way the environment can interact with anthropogenic activities. So,
Any comments from the floor on that, or experiences? Do you have any further questions on a different subject for these speakers? I might sort of add to that and what you're saying about sort of probability and using words such as chance. I mean, even with that, we find sometimes a case we had where sort of someone says, oh, there's a low chance, and then when it happens, think, oh, but it was a low chance. How did that happen? And so probability, even with simple languages, can still be hard to understand if not explained well.
yes.
And I was wondering if you had sort of some more comments on that about how you do manage to explain it well with the children. Or assuming you do.
No, well, what I do, okay, this is just a bit from my class. For example, for civil and environmental engineer, I try to explain and put always in a probabilistic concept. There is a strong probabilistic emphasis or geostatistical emphasis in my classes. And one of the key projects that I give the students is the evaluation of well protection zones, drinking well protection zones, in terms of the delineation of the whole catchment and travel time distribution. And so I have them play with simple toy models and come up with maps which are associated with high and low probability. And then, depending on the toxicity of the substance, well, I ask them to decide whether or not 1% probability is enough, actually is on the safe side or not, and then compare them against also cost in terms of potential cost in terms of human lives, how much water is contaminated by that 1% probability, how much it costs then to clean the water which has been extracted. And after some time, since they do actually their own calculation, I'm talking about the university level, since they do their own calculations, they come up pretty nicely with an idea of the impact of those low numbers. So hope I answered your question. So.
Very well. Thank you. Do we have any further questions? One here from Adrian James.
Oh. Just a timing thing. We may like to move to lunch early if there are people.
I was about to suggest the same thing. So thank you very much to our speakers, to Alberto, Michael and Mike, and to everyone who asked questions and those who listened well. It's now lunchtime, so a fun time, and please do go and see the posters. I think there's lots of interesting posters to find out about if Adrian wants to add to that.
And thank you, Joanna, for chairing the session. Yeah, we'll restart on the same time as in the agenda, following the programme.
So 2:45 back in this room. Thank you.
I was like, I'm going to meet Mike in person next week. Yeah. No, sounds good.
No, yeah, that'll be interesting to see what you guys come up with on the. Yeah. Some of it's very. The one on the herbicide sterilant problem.
Oh, yeah, that was super. We had a chat about that afterwards.